I'm holding a new book called A Brief History of the Female Body by Deena Emera. On page 74, I see images of 4 female bodies in particular. One is the elephant shrew, a tiny relative of the elephant from sub-Saharan Africa. Next is a bat. Then a rodent from Egypt called the spiny mouse. The fourth is a primate, in this case a chimpanzee. What do all these creatures have in common? No, this isn't a poster for the next Zootopia cartoon. All 4 of these groups are rare exceptions in the mammalian world. They, and only they, menstruate. What is menstruation for? And if it's so important, why do only a few mammals do it? You might think this basic and painful part of life has been exhaustively studied. It has not. Perhaps because science was for so long dominated by men, we haven't appreciated just what makes menstruation so rare. I'm Ilya Kolmanovsky, and this is The Naked Mallrat, a podcast produced by Libu Studio. Let's begin with the setting for these dramatic events. The uterus is like a little pouch about the size of a tangerine, and its lining is called the endometrium. In most of the 6,000 species of mammal, the endometrium sheds and renews gradually, like our skin or the lining of our intestines. But just a few animals shed their entire uterine lining all at once. This happens on a cycle, let's say once every month. The wound bleeds, risking infection and other delightful things. So why put up with this? The view I was taught in university was rather patriarchal. It went like this. The human fetus has a large brain and needs a lot of resources. So when an egg comes out of the ovary, the uterus builds up the thickest possible endometrium in advance. The happy embryo will then sink into this hospitable featherbed and receive nutrition. If the pregnancy doesn't occur, this thick lining is too expensive to keep up and must be discarded entirely. In other words, the purpose of the female body is to nourish. Menstruation is what happens when you miss that monthly chance to grow new life, presumably with bitter regret. This whole concept, of course, was invented by men. A better explanation developed in the middle of the 20th century when women began to study the subject. I have observed that mouse eggs develop in the eyes of rat hosts. I read that sentence in a scientific article from 1947 while working on this episode. The article was published in the medical journal Anatomical Record. It described an experiment conducted by a woman named Meredith Runner. At the time, American universities didn't even have women's bathrooms. They were hardly necessary as there were almost no women in science. Runner was an exception. She worked at a biomedical institute in Maine. Runner studied embryo development in mice with the goal of applying the findings to humans. To that point, no one had been able to successfully transplant embryos into any kind of animal, even a mouse. The first successful human IVF transplant was still 30 years down the line. No one really knew how embryos developed because no one could observe them developing. The embryo is inside and mice are not transparent. And then Meredith Runner applied an ingenious technique. She took albino mice or rats, which have fairly transparent eyes with no pigment, and she planted up to 10 very early stage mouse embryos into their eyeballs. The eye was an excellent living incubation chamber. Quite natural, she said. It was warm and supplied with blood. The transparent cornea was a window through which she could watch early development in real time. As the embryo grew, special cells on its side gripped the surface of the iris like grappling hooks. Then the cells channeled blood into the host mouse's eye. They were so effective that the eye filled with blood and exploded. At which point the experiment would end. But this did not happen every time. Sometimes the eye would defeat the embryo. There was no bleeding, the embryo shriveled up and disappeared, leaving only a scar on the surface of the iris. In no experiment did the embryo actually grow to term, and maybe that doesn't surprise you. What did you expect, trying to grow new life in an eyeball? But these two outcomes, the death of the eye or of the embryo, offered clues about what happens in a true conception. You might say that an embryo has no business being in an eye, and you would be right. But in Runner's experiments, the uterus turned out to be an even less hospitable place for an embryo. It was easier to implant a mouse embryo into a male mouse's scrotum than into a mother mouse's uterus. Something very similar to menstruation would occur in the mouse. In response to the implantation, the endometrium would shed, taking the embryo out with it. This was a dead end for Runner. She was working towards conducting IVF on mice, but it gave her a new understanding of the mother-fetus relationship. Runner used the word invasion to describe what had happened. An embryo invades and gnaws into the mother's body, while the mother actively resists. I was utterly captivated by this plotline. This was not the narrative of the nurturing womb I've been taught. A quiet revolution had been brewing in science, and that revolution was about power dynamics, about the right of the female body to defend its interests. I called an expert in biological conflict so he could explain what was really going on. Naturally, what you'll be hearing next is a dialogue between two cisgender men.
Hello, I'm David Haig. I'm an evolutionary biologist, perhaps more accurately, an evolutionary theoretician, and I am in the Department of Organismic and Evolutionary Biology at Harvard University.
30 years ago, Haig wrote his first article on the struggle, a conflict between mother and fetus during human pregnancy.
So, the early human embryo produces digestive enzymes that allow it to embed itself in the lining of the endometrium, the lining of the uterus, and then it breaks into maternal blood vessels.
Digestive enzymes. So the fetus just starts digesting, eating its way into the mother's body.
That opens those blood vessels up. It modifies those blood vessels so they lose their muscular lining that allows them to contract, and it expands the diameter of the blood vessels to increase the flow of nutrients coming to the embryo.
In most mammals, fetal cells stay within the fetus. In humans, they actually venture outside and take over the mother's body. Why? Because the human fetus has a large, hungry brain? Well, dolphins have large brains, but nothing of the sort happens with them. In dolphins, the mother's blood vessels come in contact with the fetus to supply oxygen and nutrients, but the mother's blood remains with the mother.
So in the human placenta, unlike a dolphin placenta, maternal blood is essentially leaving the maternal blood system, flowing through an internal space of the placenta, and then returning to the maternal body. One of the consequences of that is that during pregnancy, maternal physiology is coming partly under fetal control because the fetus is pumping hormones from the placenta are being secreted into the maternal blood, and they're taking over maternal physiology.
Hundreds of maternal vessels supply nutrients to the uterine wall. Into these vessels come the grappling hooks, the fetal cells. They destroy the muscle cells of the vessel walls. The vessels can no longer contract and become fully dilated. Blood flows into the placenta. The mother has no control over what or how much the fetus takes from this blood. But the fetus can add its own hormones, sending them into the mother's body. This invasion is so efficient that a human embryo can implant into unexpected parts of the body. This is called an ectopic pregnancy, and it's a dangerous condition. Other parts of the body don't have the uterus's protective shield of endometrium. Think of that popping eyeball in Meredith Runner's mouse experiment.
And there are women who've had pregnancies come to term with an abdominal pregnancy where the embryo, there's big risks involved in this, but where the embryo's not sitting in the uterus, it's actually sitting in the abdominal cavity and is implanted on the intestine and whatever. And so despite people talking about the important exchange of signals between mother and fetus, what I see is a remarkable little exchange of information that the embryo is just establishing its blood supply pretty well wherever it can find in the body.
So conception is not a particularly sentimental process. The first phase of pregnancy is essentially a hacking. The mother's bloodstream ends up in the fetus's control. And how can the mother retaliate? Here we'll learn the answer from a younger biologist, herself a mother of 4. She's the author of the book I was reading at the start of this episode.
My name is Deena Emera. I am a senior scientist at the Buck Institute for Research on Aging. My background is in evolutionary biology. I've spent lots of time studying the female reproductive system.
To begin with, I asked Emera about those 4 mammals in her book. Remember, primates, elephant shrews, bats, and spiny mice. Why do they menstruate? Emera said, all those years that we were searching for an answer, we were asking the wrong question. Menstruation is actually a side effect of another, more important common characteristic of these animals. Emera says pregnancy in mammals that menstruate differs from pregnancy in others. It's got to do with the hormone progesterone, which makes pregnancy possible.
So the lining of the uterus, I kind of think of it as existing in 2 states, the non-pregnant state and the pregnant state. And the behavior of the cells are very different. In the non-pregnant state, the cells can grow, they can become, the layer of the endometrium gets much thicker because the cells are dividing actively. In the pregnant state, the cells can't divide anymore, and their functions are totally different. The cells get closer together, very different functions of the cells that are in these 2 states. In menstruating mammals, when progesterone levels rise, the state switches from the non-pregnant state to the pregnant state. In all other mammals, that switch doesn't happen.
So we're getting close to the answer to our main question. We simply become a little bit pregnant before actual conception. Let me explain this. All mammals produce progesterone shortly after the ovary releases the egg. But in those rare mammals that actually menstruate, the endometrium reacts to that progesterone. It begins to transition into a special as-if pregnant state. It's preparing for fertilization. If that doesn't happen, the progesterone level drops and the endometrium breaks down. This is what menstruation is.
So the real difference is why do, in some species, those cells transform into the pregnancy state before the animal is pregnant. In all other mammals, that transformation happens at a time that makes sense. So I'm going to invest all that energy in changing these cells from the non-pregnant to the pregnant state. I'm going to do that when I'm actually pregnant. But in menstruating mammals, that transformation happens during the female cycle. It doesn't matter if she's pregnant or not. And if she doesn't get pregnant, since those cells need progesterone to stay alive, if her progesterone levels are going to fall if she doesn't get pregnant. That's one of the things that pregnancy does, is keep progesterone levels high. It's like the hormone of pregnancy. The cells die and the female menstruates.
So why do we And our comrades in menstruation employ this tactic. Why do we simulate being a little bit pregnant before any actual pregnancy?
So that's the second part of the question. Why? Why do the cells do that? Well, I wish that I had a solid answer for you.
We don't know. It's the 21st century, and we still don't know exactly why we are such strange creatures. But there is one strong hypothesis.
The best we can do is look at what other things those animals have in common. And one of the things that they have in common is they have much smaller litters than the average mammal. So many of them are having one or two, babies per pregnancy, as opposed to like a house mouse that has, can have 10 babies in a pregnancy. So they're investing a lot in each baby. In primates, pregnancy is very long. In some of these bat species, pregnancy is pretty long. So they're investing a lot in each baby. The other thing that I've become very interested in is rates of miscarriage in these species. So when you're investing a lot in a pregnancy, you don't want to invest in a baby that's not going to make it, right? You want to, females have all these mechanisms in place, not just humans, but all female mammals have all these mechanisms in place to maximize the chances that they're going to have a successful pregnancy. And if there's something wrong with the baby, chromosomally or developmentally, whatever it is, our bodies have evolved to try and detect that problem as early as possible and, have a spontaneous abortion of that baby if is likely not to make it.
An extraordinarily high percentage of our embryos develop with abnormalities. Perhaps that's why many mothers experience early miscarriages, often without knowing. For us, pregnancy is a huge investment. Evolution must have provided the mother's body with some means to detect problems early on. The mother's adversarial relationship with the embryo is helpful here.
So one thing I haven't said about the transformed the transformed uterus or pregnant uterus versus the non-pregnant uterus is once the cells of the uterine lining have become, have turned into the pregnancy cells, they act as embryo sensors. So they basically can detect if there's something off with an embryo and actively prevent the embryo from implanting. And so that's the idea, is that if you can turn these sensors on earlier, then those cells will detect a problemed, an unhealthy embryo earlier. And the body will quickly rid the uterus of any unhealthy embryo that's starting to develop and start again.
So the main role of this unusual endometrium is to prepare for the invasion several days before conception occurs. But not because the mother needs to get ready to nourish the embryo. No, she needs to get ready to kill it. Menstruation happens if the embryo fails quality control. And over the course of evolution, this mechanism became regular, just in case. Menstruation happens on a cycle, embryo or no embryo, as a precautionary measure. Or it doesn't occur, and then conception happens. Let's suppose menstruation doesn't occur, and the pregnancy continues. From here on out, both organisms, the fetus and the mother, ought to cooperate to reach childbirth safely. Ideally, the process maintains equilibrium. The fetus consumes resources, the mother replenishes them. But the reality is much more complex. I asked Emera how she would describe the relationship between the fetus and the mother in humans.
That's a great question. I would describe it as someone used a great term. There's coopetition.
Wow.
It's a combination of cooperation and competition. And that's how I see it. It is this push and pull between mothers and babies. And that pushing and pulling has been happening for millions of years, hundreds of millions of years. They have to cooperate because both parties obviously want to make it. The mother wants the baby to make it, and the fetus wants to make it itself. But there's this underlying competition as well, because mother and baby are not genetically identical, and the father has his own interests. In the current baby, I'm sure that Professor Haig talked all about that with you.
So the conflict continues even after the first barrier, menstruation, has been passed. In almost any situation where their needs are opposed, the fetus will prevail. And yes, David Haig, the expert on biological conflict, told me 2 blood-chilling stories about conflict in our bodies during pregnancy. First, he told me, pregnancy hormones can interfere with the uptake of insulin. Insulin helps mother regulate her blood sugar. Well, back to Haig.
If mother is resistant to the effects of insulin, when she takes a meal, her blood glucose will be elevated for longer, and the embryo has direct access to the maternal blood and so is getting more nutrition. Mother counters that by increasing the production of insulin to gain control of her blood sugar. And in most pregnancies, the woman doesn't become diabetic, but in a subset of women, and I think it's about 10%, the maternal pancreas can't produce enough insulin, and so she then develops high blood glucose during the pregnancy. It's associated with complications for the baby, but those babies tend to be born bigger with greater fat supplies because of the elevated glucose in the maternal blood.
It's a condition known as gestational diabetes. The baby happily sucks up that extra blood sugar, but the mother's blood sugar levels remain dangerously high. The second conflict has to do with a condition known as preeclampsia. It's a common condition in pregnancy that causes high blood pressure in mothers.
All sorts of things can go wrong during preeclampsia. You can get heart failure, liver failure, kidney failure, cortical blindness. So why does this occur? I think it's a very high-risk adaptation of an embryo to increase the flow of blood to the placenta.
If the fetus isn't getting the blood flow it needs, the mother's blood pressure increases to compensate. That's good for the fetus, but dangerous for the mother. Even if the mother withstands all that, she still has to give birth. When humans were evolving, that's when the mother might have paid the final and greatest price for the entire endeavor. Why? Why does everything have to be so dramatic? Well, here enters the key culprit, which is actually the father. To be more exact, the father's genes.
Because mother and embryo are not genetically identical, conflicts can arise. Things go wrong in pregnancy all the time. If a woman becomes pregnant, you book ahead of time to go into a hospital because you're anticipating things go wrong. And why should that be so? Why shouldn't pregnancy work as efficiently as your heart and your liver does? And the difference there is that heart and liver are all parts of the same body, whereas in pregnancy you've got 2 different individuals who have common interests, but they also have conflicting interests.
Mothers have evolved to maximize the number of healthy babies that they produce. Sometimes that means discarding unhealthy embryos. Fathers, however, have evolved to maximize the chances of each embryo they help create. Because who knows if they'll get another chance to plant their seed. That conflict between a mother's and father's genes becomes a conflict between mother and embryo.
And so I think of pregnancy more like a political dispute. When we think of politics, it's not necessarily efficient outcomes. You say, why can't these 2 sides agree? Wouldn't they be better off coming to some agreement? But politics doesn't always find those agreements because of failures of communication and just that there is a short-term advantage for gaining a benefit for self, for the embryo at the expense of the mother, or vice versa. And they have long-term costs, but that doesn't necessarily mean you get to the efficient outcome.
Evolution can be makeshift and crude. Menstruation was an ancient mechanism for the early termination of unwanted pregnancies. Now it's become part of the mandatory program. Pregnancy itself is the result of a complex system of checks and balances where each side fights for his or her interests, even if they seek to cooperate. How did reproduction in humans come to involve such monstrous conflict? In a sense, humans are one of nature's crowning achievements. We are the pinnacle of the arms race between maternal and paternal genes. The more determined the invasion of the fetus became, the stricter the selection by maternal genes. The result? A pregnancy where the fetus receives maximum resources and develops a large brain. This leaves one question unanswered. Why do humans create such a high percentage of poor embryos in the first place? It turns out this question is at the crux of the matter, and Emera's book has the answer. It's all about sex. Human sex is unusual. Typically, mammals engage in sex only when the female is in heat, around ovulation. In humans, ovulation is concealed, hidden. There are no obvious signs of it. So sexual activity is spread across the days of the cycle. That might mean more time passes between sex and conception. The egg and sperm cells are older and degraded by then. That might lead to a high number of poor quality embryos. However, this spreading out of sexual activity also serves to solidify bonds in monogamous pairs, a key factor in our evolution. Other primates have a simple way of determining whether a female is of interest. She's either ovulating right now or not. Humans lack this indication, so couples choose other reasons to get together. And those reasons keep them together throughout the entire cycle, across cycles, and over many years. The fetus receives not just one parent, but two loving parents. This has enabled sapiens raise offspring that require a lot of care, but also to do so more frequently. Hidden ovulation is beneficial, but it leads to a high percentage of poor quality embryos, necessitating menstruation as protection. It's often said that menstruation leads to less sex, but in reality, it exists because humans have more sex, more love, and more collaboration. And this is the key to our success on this planet. This was The Naked Mole Rat, a podcast from Liba Studio. It is produced by Andrey Borzenko, Anastasia Medvedeva, Danil Astapov, and Kirill Sychev. Our sound editor is Alexei Vorobyov. And I'm Ilya Kolmanovsky. Now that the main part of the episode is over, I'd like to use this moment to share something funny that happened during my interview with David Haig. I have 3 biological children, and I have absolutely idyllic memories of each stage of their origination. After working on this episode, I completely lost my peace of mind. What's it like to know that you were the cause of 3 such invasions?
Right. David, how do you live with all that knowledge? I mean,
how do I, what?
How do you
live with it?
And how do you sleep at night with all that knowledge? I mean, do you feel yourself accountable for what's going on there? I'm sorry if that's a delicate question, but do you have kids? And
I've got kids, but I am different. I am different from my genes. And another way I put it is my genes don't care about me, so all of our emotions, and that's our misery as well as our joys, our hatred as well as our love, they're all ways that genes have evolved to transmit themselves to the future. And whether they get it through our misery or through our happiness is irrelevant to them. And since they don't care about me, why should I care about them? I respect them. They're very, very powerful, but they're not who I am. I've got to live with them, but it doesn't mean that they're in charge.
So, I am not my genes. Thus sounds the last consolation of the true feminist father. Stay with us.